Good morning. My name is Robin, and I will be your conference operator today. At this time, I would like to welcome everyone to the CA APM Wiley Global User Community Webcast. All lines have been placed on mute to prevent any background noise. After the speaker remarks, there will be a question-and-answer session. If you would like to ask a question during that time, simply press star, then the number 1 on your telephone keypad. To withdraw your question, press the pound key. Thank you. I would now like to turn the conference over to our host for today, Mr. J.P. Gagan. You may begin your conference, sir.
Thank you, Lisa. So welcome, everyone, to this edition of the CA APM Wiley Global User Community Webcast. And we're happy to have a presentation by a vendor who works with CA and APM Introscope in our space. So I'll introduce the speaker in a minute. I also want to mention that at the end of the webcast, there will be a poll. I would like to have your feedback. I will be asking you a couple of questions on, firstly, what you think of this webcast as usual, but also we are planning some customer type of event. I would like to have them in your region if possible, so we'll ask you a couple of questions about that. With that, I'd like to introduce Graham Gillen, who is Director of Product Marketing at Netuitive. Graham?
All right. Thank you, JP. Hello, everyone. My name is Graham Gillen. I'm the Product Marketing Director and CA Partner Manager for Netuitive. I'd like to thank Mary Greenig and the officers of the CA APM user community for allowing Netuitive to present one of our major joint customers today. And what we hope to engage you with is a case study showing how specialized third-party analytics tools like Netuitive can complement the performance management suite offered by CA to help ensure and improve the performance of critical applications like the point-of-sale systems that you'll hear about today. Our presenters today, we're very glad to have them, are Jay Patel from Netuitive and Amy Hansen representing the customer. Jay's a senior systems engineer at Netuitive. He has over 12 years of experience working with various APM tools and strategies, and he's one of the absolute best SEs at Netuitive. Amy Hansen is the manager of systems engineering and production control, responsible for the point-of-sale system that you'll be hearing about today. And I know that it's very hard that Amy had to jump through a lot of legal hoops with her company to be able to present today. And in fact, we can't even officially name that company. So we hope you'll understand that if you ask a certain sensitive question, she may politely respond with a no comment. So hopefully you'll be okay with that. But with that, I'm not the star of the show. It's really Jay and Amy, so I'm going to hand it over to them and for the main presentation. Thank you.
All right, excellent. Thanks a lot, Graham. The voice that you're hearing right now is Jay Patel. I'd ask if anybody is not on mute right now, can you just let me know if I'm just speaking to nobody, or can you hear me?
Oh, we can hear you.
Okay. Good. All right, good. Appreciate that. So one thing I'd like to start with is, as Amy and I prepared for this, we realized that the title was just slightly misleading. So I just want to preface this by saying this is more of a case study as opposed to a success story. We want to go through the topics that we want to cover here led to a lot of conversations between the on-site CA team and the internal application support team. So our hope is that, as we go through this, the questions that we had to ask and answer are questions that you'll have, and that there'll be some interesting Q&A at the end. So we've given ourselves plenty of time. Also, you're allowed to ask questions in line, so feel free to interrupt, and let's try to make this as interactive a session as possible. All right, by way of agenda, what I want to do is just give you a brief description about the technical architecture and infrastructure that we have at play at this customer. So I can't go into details, but I can give you some of the more technical aspects of the way that all of the bits are put together. And then I want to talk briefly about the interest, or I'll have Amy. Amy's going to actually talk briefly about why they went to investigate the predictive analytics, a predictive analytics solution, right? So what were the motivations behind that? How did you even get started thinking about it? Then we're going to go into a semi-detailed explanation of the CA and Netuitive technology integrations. So there were several that we had to go through in order to put this all together. And so that's going to be sort of the meat and potatoes of the how this all works. And then finally, with all that background in place, we'll go through a case study, which we call at Netuitive a trusted incident. That occurred late 2012. Obviously, the specifics and the numbers are going to be hidden, but you get the overall flavor of sort of the tie-ins between the business, between the IT, and some of the numbers, and also some of the types of information that we've been doing predictive analytics on. All right, so I'm moving two screens at the same time here. Whoops. All right, so I'm on slide 2 at this point, just to make sure that the video is moving along with me. About the customer, it is one of the largest U.S.-based telco providers and has over 2,200 retail stores across the U.S. The systems that we're going to be talking about today are the retail systems, right? So the things that support the stores, support the reps in those stores, and all of the things that would be needed to, let's say, buy a new phone, start up a new plan, look up a new phone number, all those things that you do when you walk into a retail telco to pick up a new wireless phone. So the point-of-sale system is completely dependent on the IT systems, right? If you can imagine, in order to get a phone to a person, you've got to make sure you don't duplicate a phone number. You've got to make sure that the systems are provisioned, that that once that SIM card or the phone itself, the device is made live, that everything is going to work properly. So without the IT systems in place, you're causing your reps all sorts of grief. And one of the things that when we first started was that one of the executives believed that failures in the IT system had a direct impact on the sales in the stores, but they couldn't prove it, right? There was nothing that actually could prove this in a way that says, well, these systems are critical, and it's not just that somebody's going to find another way to get this done, right? So we'll go into that in the case study in a little bit. So the client actually has 4 geographically dispersed areas, each of which is serviced by 72 JVMs, and each one of those JVMs runs several point-of-sale application instances, right? So this is done for failover purposes, right? You can go to any one of those 72 JVMs and do business completely. So if any one of them is down or failed or restarting, you'll just get load balanced over to another one, right? So they've got some sticky session stuff that adds to the complexity, but I won't get into that just yet. For the most part, you can just imagine it's like a round-robin algorithm. You pretty much get to go to whichever JVM is going to service you fastest, right? So while that system is very highly available, very fault-tolerant, it does introduce a lot of challenges with respect to monitoring, right? So CA was chosen as one of the technologies of choice to monitor this very complicated infrastructure, and is still the forensics tool of choice, right? So the domain experts in each one of the silos in each one of these technologies absolutely rely on a day-to-day basis on these consoles to do the job. So last year, the customer, who, they pride themselves as being the best-of-breed provider in this space, right? So they were endeavoring to improve this already top-notch solution, right? So there was nothing wrong with this. There's no specific item that was, falling down. This is about improving their systems over and above what they had already, which was fairly sophisticated. So I'll let Amy speak to the motivations behind that. And with that, let me introduce Amy, who is one of our, who is my customer, but is actually, Amy, if you can start with your title, and we can go from there.
Okay, thanks, Jay. This is Amy Hansen. I'm an IT manager for production control, like she said, for the point-of-sale systems. So to get into our motivation for this integration, we use Interscope right now, and for our focus on the customer, we try to always put the customer first, and we are constantly monitoring our systems with numerous tools, as Jay mentioned, and we're constantly trying to get ahead of the issues. So Netuitive, we looked at Netuitive to provide the holistic view, incorporating all of our system statistics with our revenue, the sales data, to see how it's impacted. So our availability targets have gone up. So we looked for a tool to do analytics on all of our data to help meet this higher target. And we need to be able to work on an issue proactively before the customer complains. That's our main motivation. So Netuitive provided the analytics to learn what is normal and to find the anomalies. And this will free us from setting hard thresholds. So thresholds did not work for us. We do have lots of systems with hard-coded thresholds, but they produce a lot of alerts and notifications and a lot of noise. So we were looking for a tool that would give us that important high-confidence alert ahead of any customer impacting failure. So also this analytic tool, we felt that the fact that it can consider Monday morning traffic different than Saturday afternoon traffic and tell us that this is abnormal for today was one of the highest factors that led us to this solution. So I can hand it back to Jay, and he'll go into how Netuitive was implemented.
Excellent. Excellent. Thanks, Amy. Appreciate that. And so Amy's going to be on towards the end of this session. If you guys have some specific questions about the motivation, about how you even get started with something like this, or what kind of initiatives need to be put in place from a top-down level in order to see some success from this stuff. I'm going to get into some of the meat and potatoes of this installation or of this solution right now. And with that, I'm going to start with the concept of how this IT all kind of holds together. So transactions traverse a large number of technologies here, right? So they start out, they start their life out, on the client machine who interacts, the reps who interact with various applications that they have in the stores, be it, little mobile things on iPads or Android devices, and as well as consoles, right? So they might even have a little desktop which they use in order to get somebody through the process of provisioning a new phone or a new plan. And what they do, what ultimately happens is, this goes through that set of JVMs that we saw, and there's JSPs, AJAX, all sorts of fun stuff on the front end. In the middle tiers, they have, a lot of queuing technology. So what you see there with respect to queues is OMQ based. And what I found was OMQ, very, very fast, very cool technology, not a lot of logging or monitoring built into the thing, right? So that was an interesting integration that we had to do. And then ultimately this goes all the way down through web services, through third-party tools, through the mainframe, and also into back-end databases. So there's everything here, right? So transactions aren't, it's not just a three-tier architecture. This is a multi-tier architecture that needs to be put in place just because of the different types of functionality. And we're not going to go through all of the different patterns that are here, but you get an idea from this slide all of the integrations that we had to work with. So from a customer experience perspective, we got the CEM on the front end, which is monitoring sort of the end-to-end transaction timing. From an APM on the JVMs themselves, we've got Intrascope that's providing all sorts of rich data that we're mining. From the network perspective, ADA, we've got so that's also coming through the CA interface to Netuitive. CTG, which is what's going to be of interest to this particular use case, happens to be the one that this case study is going to be centered around, but it could have been any or all the above here. We also married that data with some data that this provider collects for each one of their stores. So they know, the total sales for a store. They know how long a rep is standing around, how much time there is between people that have walked into that store. So they're fairly sophisticated in the amount of data that they collect specifically around the store. So we actually leverage that as alongside of all the data that's coming in through, various CA integrations in order to get a holistic picture across the entire environment. So most of that stuff, most of the data that you're seeing here, so anything with the little CA logo on it in that diagram, is coming in through the CL workstation command. We just query against it, set up a regex, and that filters out the information from a specific mom or several moms and puts that together in the Netuitive interface, which we'll see next. Okay, all right, so I'm going to go through the case study. So with respect to this case study, what we're going to go through is the timing of events, and I'm not going to go linearly through this, but what you can see on the screen is the first time that anybody in this environment knew that something was going wrong was the trouble ticket at 14:22 or at 2:22 in the afternoon. What that was a call into the help desk, right? So somebody's actually complaining that, hey, something's gone wrong, right? If we go back in time to the 11:55, what you can see is that little yellow dot is that Netuitive was actually starting to show some signs of what we call an anomaly, right? So it's not an outage, nothing's gone wrong with the system, nobody's complaining about anything yet, but we're seeing some anomalous behavior, right? Something that we haven't seen before. At 2:10, Netuitive alarms because of actual back end. This is where we'll get into some of the screenshots for this, but the actual CTG, or Kicks Transaction Gateway, to the mainframe was actually starting to slow down at that point. So that's the first time that performance that could have been measured by the or seen by the end user would have been spotted there. At about 2:15, Netuitive recognizes that things are starting to go very, very bad, right? We've got stuff on the front end, stuff in the middle tiers, the queues are backing up, the mainframe response time is very, very slow, and at that point that's the point at which this next screenshot, which I'm going to show you, is kind of lighting up, right? So if you can imagine, let me just move to that next screenshot. If we can imagine, when you see something like this on the screen, this gives you a view of all of the componentry that goes into the set of transactions that make up this functionality, right? So, all that stuff that we were talking about with respect to, provisioning a new phone, getting a phone number, a new plan, all that stuff can be kind of modeled on one screen that you're seeing here. And what you're actually seeing here, I'm not sure if you guys can see my mouse, but let's start with, let's go from right to left. You're seeing the client-side queues, right? So that's the JVM side of the queues that are going onto that Oracle queuing system. And so what we're seeing there is, everything looks fairly reasonable, right? You see the little green bars, fairly easy to understand there. From a back-end perspective, those are all of the what we call sub-applications that support this, all the transactions that we're seeing here. The struts actions, obviously that's the actual meaty part of the code that the JVMs are running. The JSP is in front of that, and you can see some red and some orange and some green there. We can get down to the specific JSPs that are misbehaving, right? In this particular case, what we do is we group them up into functional, rather than showing every individual page and every JSP that's out there, we group them up into, it's sort of almost like buckets of application space, right? So this one might be for provisioning a new phone. This other one might be for looking up a phone number, right? Or this other set will be looking up a phone number. From the application server perspective, again, that is actually a cluster of application servers, so that green box represents all 72 of the JVMs in this particular area. From the sales data perspective, what you're seeing there, the little yellows that you're seeing there, that's actually based on the total sales for that region. Okay, so there are 6 regions in this area, and each one of those regions is separately metered. to say, hey, the stores within this particular region, they're still behaving normally. They're still, selling X number of phones per, every 5-minute cycle that we're seeing here, and trending wise, we're doing the right thing. We're doing the same thing that we did last Monday, as Amy mentioned earlier. So CEM transactions that you're seeing there, again, that's a group of them. That's a cluster of customer experience, right? And you're seeing that it's starting to degrade at this point. And if you look at the CTG, the CICS Transaction Gateway, that's where we're seeing red, right? So we're seeing there's 3 IBM mainframe instances, and all of them are misbehaving in this particular situation. So again, one of the things I mentioned is this screenshot was taken at 2:22, right? So this is the screenshot that's taken when the customers actually started to complain. So it's very difficult at that point because everything's lit up, right? You've got red across, several different components, and what you really want to see is, where did this come from, right? What led up to this behavior? What led up to the fact that we're now starting to see some sort of degradation? So we'll show you where that came from. With respect to the CTG health, the first thing that Netuitive saw was at 11:55. Historically, we were seeing more traffic than we had ever seen before, right? So not that anything was wrong with the system, not that the behavior was, meeting or violating some sort of threshold. We simply saw that we hadn't seen throughput through that mainframe instance at that level ever before. And so we dropped that health score, what you're seeing here, from 100 to around 85%, right, or 75% here. And that health score is dropped only because we haven't seen this. It's anomalous, right? It's not an error, not a failure, it's just anomalous. Then later, at 2:10, what we actually see is a spike in the average response time, right? So as soon as you see that spike in average response time, the way that Netuitive was tuned was, the customer understands that when their mainframe slows down, it is very, very sensitive to mainframe slowdowns, right? The queues back up almost instantaneously. It's a cascade failure. It's very difficult if that mainframe's not processing at optimal levels for them to triage these things, because it just has to work. All right, so those are the factors that led up to this particular health degradation. So at 11:55, as we said, you can see it start to degrade. So that's the first indication that something's going wrong. Then at around 2:22 or 2:30, that's where we see the health, this concept of health that Netuitive has, actually drop down to a low level here, right, almost to zeros at times. After that, so around that 2:10 to 2:30 time, we can see that it start to cascade to the front ends, right? So you can see the customer experience starting to be affected around that 2 o'clock. We can also see that intrascope data that's coming in is outside of its normal band as well. So the screenshots are a little bit small here, but what I'm showing you here is the green bars that you're seeing is a baseline. Right, so that's where Netuitive expects this particular metric, which happens to be the average response time for, let's say, a back-end component, to be within. This blue or purpley blue color that you're seeing here is the contextual band. So how does this particular metric, like the average response time, move with respect to other metrics that we're collecting, right? So if we know that the back-end performance is intimately related to the depth of a queue size, then those things tend to move together, right? They tend to move in related patterns. So Netuitive is constantly doing analytics to on all of this CA data that we're collecting to say, well, if the queues get larger, generally our average response time goes up, and so that's why we expect this thing to be within this blue band. When it's not, that's what we consider anomalous behavior. That's when we're starting to send these trusted alerts. All right, and so finally, what we were able to do, and this was for that the exec that I mentioned earlier, who believed that the IT performance was related to store sales, was actually able to prove it. With respect to this particular, I guess it's a degradation. It wasn't really an outage. The Northeast sales were affected, but not the most. But the South area sales had a huge sales drop, right? And it just happened to be because of the time. Because it was 2 o'clock, that's when the South generally has most of, or is conducting most of its business. And you can see there very specifically in that little bounded red box that there was a drop in the net, or the sales amount gross. Okay, so that's the metric there, sales amount gross that has dropped. And below that, the average server response time for that particular mainframe, or that set of mainframes, jumped up. So what they were able to do was specifically tie, from a mathematically correlated perspective, the slowdown in that mainframe to dollars not being spent or being lost in their systems. So we can't give you the exact dollar amount, but one thing is that they were actually able to measure that effect. So getting back to this, the timeline perspective, what would have happened here, or why is this not a success story, and why is it a case study? The actual time to resolution, if we think about it, the traditional time here was 14:22, so 2:22. The customer is notified of situation. Because of how good they are actually at solving these things, this was actually a non-trivial problem. It took about 40 minutes to resolve that issue. Now, if we think about this, if Netuitive is alarming at 11:55, and the first indication of trouble actually happens at 2:10, we would have actually been able to resolve this issue well within a time frame that would have completely avoided this outage. And so there's a whole, I guess our next step initiative with this client is to work on the concept of operational adoption, and to say, hey, these alerts that we're getting, these anomalous behaviors that we're seeing, let's go pay attention to those, right? Let's start dealing with the problem earlier in the cycle. Let's not wait until the customer actually is impacted before we start resolving this thing. And so that's where we're going in the next little while. And that's why we wanted to talk to you about this particular case study. So, what is it that we're going to do better next time, right? And how is it that we're going to use this trusted alarm that we've got at 11:55, believe that something could potentially go wrong, and resolve that issue prior to anything actually happening on the environment. So that's actually what I wanted to cover off today. If you guys have any specific questions or answers, both Amy and I can address them. Just if you can just, Amy is the customer, and she can give you details about the environment as she can. And myself, I worked on the technical integrations and also the mining of that CA data plus the extra integrations. So appreciate your time. If anybody has any questions, please feel free to ask them now.
As a reminder, if you would like to ask a question, simply press star 1 on your telephone keypad. We'll pause for just a moment to compile the Q&A roster. Again, to ask a question, press star 1.
Also, you can use the Q&A link at the top of the live meeting to ask a question if you're not on the speaker audio.
We do have an audio question from the line of Sarit Meharana.
Hi. Apparently, the heuristic didn't work for you, right? So, with regard to the number of metrics that you are forwarding to Netuitive, is that a finite number, or is that everything that's collected by Interscope and CEM?
Okay, so can you guys hear me? Okay, all right, I'm gonna respond to that. So this is Jay. It is we could have brought in everything with respect to metrics, but what we found was that each one of the technologies, it was better to go and find what the KPI was, right? So what the key performance indicator or the early indicator was. So the more refined that we get with our approach, the less metrics we have to bring in. So at first, we just brought everything in, every metric we could get our hands on, right? And we let the engine, the Netuitive engine, start to see what correlates, right? Which ones are working together, which ones are actually related to each other. And what it did was it eliminated all the ones that were redundant first. Those are trivial. And then after that, what we started to find was there was some, metrics in there that are just false, right? They would, they're jittery, and so they would just go up and down. They had no relationship to, things that we would consider early indicators of outages. And so we started to pare them down as time went on. So that process, took a few weeks, actually. At the end now, what we've gotten down to is probably that entire infrastructure that you're seeing works on 3,500 what we call managed elements. So there's 35 distinct green, red, and yellow boxes in that environment. And each one of those probably has between 100 and or between 3 and 80 metrics each. So does that answer the question?
Yes, thank you. And so how often do you collect? Is it near real time, or how do you interface with the Interscope data?
So what we found was, this is a very interesting question. It's a good question, actually. Initially we thought, well, the faster that we get it, the better, right? We want as quickly and as early warning of any impending doom as possible. So we went and looked to see, what sample rates we could get from the various different integrations. We right now have standardized on 5-minute analytic cycles, and what that has done is it's smoothed out some of the jitter that we get, because if you think about it, the environment is very robust, right? You've got 72 JVMs, and a lot of hits, but when you're spreading those hits per day across 72 JVMs, you do get some sporadic. Somebody will be sitting on one JVM for a little while, another one will be completely dormant, right? So with 5-minute analytic cycles, we get a good amount of predictability. As well, we get that warning. So every 5 minutes, there's a potential that something could be analyzed and flagged as being interesting to go look at.
Okay. And now, was the MOMS limited to only this application, or because you know how sensitive the Interscope MOMS are to the queries?
Right. So actually, the MOMS are supporting several applications. Amy, I believe there's at least 4 big applications like this per MOM. Is that correct, or are there even more than that?
I think there's even more than that. We just concentrated on one for this proof of concept.
Right. So what we did was we used the like a regex expression to filter out anything specifically for this application. Then we further refined that to pick out the back end and front end components that made the most sense. Right. So that's actually when we first started with this, we did actually put a little bit of load on the MOM itself. But then after, once we refined the set of metrics that we were interested in, that reduced the load. But I mean, we're still pulling a lot of data from the MOM, and it stands up without a problem. For whatever reason, it is actually very robust. It's keeping up no problem with over. I think it's over 1 million metrics every 5 minutes that we're pulling in from there.
Great, thank you.
And at this time, there are no audio questions.
So, Jay, there's some questions in the Q&A at the top. Can you see them?
I am going to check. All right, some Q&As.
There are 2 questions. First one from Mike. Thank you, Mike, who asked, I guess we touched on some of these, but I guess more specific, how does Netuitive get the data from CA APM? What's the data collection frequency? I think you answered. What are some examples of the APM or infoscope metrics that you are collecting?
Okay. All right. So the one frequency, we put it at 5 minutes, and that just happened. That's arbitrary. It's the one that works well here. Our typical is 15-minute analytic cycles, and what that gives us is a nice smoothening of the data sets. So we get good patterns there, good predictive patterns. The second thing is it doesn't put a significant load on the collection. So, like somebody had mentioned that the moms themselves, you start hitting that thing all the time, you're going to obviously put load on it to get that information. And then so we get most of our stuff from the mom, right? So all of those integrations, we use the CL workstation command to just issue, it's basically a command line, call via the jar, the CL workstation.jar, from what we call our remote collector, which is a separate component designed specifically to, store and collect that information. We also get data from these things that we call T4-R files. That's the OMQ data, right? So the Oracle MQ queue, how many messages were processed by a particular queue in this given 5-minute period. That data comes from some flat files, and then the BAM data is delivered to us via SFTP every 5 minutes every 5 minutes as well. The BAM data is delivered to us via SFTP, file drop to a particular directory on a server, and then is consumed and then put together. So there's various different places that we get the data. It doesn't matter that you don't have to have all of you don't have to have the same sampling rate for each one of those integrations, but it's good. What we generally try to suggest is have at least 2 samples per analytic cycle, right? So what Netuitive likes about that is that, you get one set of data, you get a second set of data, we average that data, and then we use that in our analytics, right? And that eliminates the, if you've just got one sporadic piece of data, or, if something's off and, you miss one of those collections, it doesn't send the mathematics all over the place. And then what's the last part of that infoscope metrics that you
And some examples of metrics that are being collected.
Okay, all right. So some of the good metrics that we are at, total sales, total gross sales, right, or gross sales. That's a good metric for us. It follows a pattern throughout the day. If you're talking about the East, around 10 a.m. Or 11 a.m. till around 2:33, that it kind of goes up and is its highest period, and then towards the end of the day and overnight, that number drops down, and it does that what Amy mentioned, that whole idea of BAU or business as usual. What's the pattern, right? What is the normal pattern for these things? Another good metric that we were able to gather was from the KIX transaction gateway was the total RPI, or responses per interval, for a given resource, right? Whatever happens to be, if it's a mainframe call, if it happens to be a web service call, whatever it is, coupled with the average response time. So if I can get the average response time, the ART, and the RPI, responses per interval, then I've got a good measure of how busy that thing is and how well that thing is performing. All right, and those are the 2 that I would say are the minimum. Other indicators, it depends on the technology. If you've got storage that you're watching, maybe there's disk IOPS, reads writes. If you've got a database, scans, the time for a query, or the number of locks that you have. Right, those are the types of metrics that we like to get. So that was a long-winded version of that answer. Sorry, I'm going to try to go through it a little quicker this time. Should I go to the second question from Tyson?
Thanks, Jay. Yeah, you have it there from Tyson. I guess question to Amy. How complicated was the setup and ongoing maintenance? And have there been success stories of seeing early indicators resulting to avert problems?
Okay, well, I would say the setup was I would say, pretty complicated. Jay and John have been on site here for a couple months already, and they did most of the setup. I know the service model has been tweaked quite a few times. So I would say it is a little complicated, but I think ongoing maintenance is not going to be that much of a problem. Once it's set up, I think the data is just going to flow unless we have a totally new architecture. I don't think maintenance is going to be that much of an issue. What we are building up now is a knowledge base, which is going to help us react to these incidents better. So we are still in the operational adoption phase, like we said. So we don't actually have notifications going out yet. So we don't have success stories yet where we have averted problems. But we're doing it both ways. We're doing negative testing to see what an early indicator will look like. And we're also, like this case study is, when a problem does happen, we look back and see how Netuitive would have responded.
Thank you, Amy. Next question from Charlie. Thank you, Charlie. What are the principles behind the engine, behind the Netuitive engine?
Okay, so I will do the high-level version of this. I think if you want to really get into this, our website is a good resource. As well, I can get in touch with the math guys because there's 9 technology patents, which I've read the patent names and I can barely get through that. So bear with me for a bit on this one. Ultimately, what we do is multivariate regressional analysis on metrics, right, on APM metrics. So how that differs from what you might be watching. We'll do the baselining, right? So you'll take a metric and you'll baseline it and see where it is throughout the day, time of day, day of week of, or hour of that day in that particular month. We'll do all of that, time series-based analysis. We'll also do correlation between metrics. So once you get something into the engine, what you're actually doing is watching how something moves, how a particular metric moves, with respect to other metrics that are in that particular, in the engine as well, right? So what we do with that is we develop these correlation coefficients. If the correlation coefficient is high enough, then it's considered a candidate for a correlated metric. And so when something becomes a correlated metric, it starts to affect what we call the context, the context band. What I showed you with that little blue band, so when you watch a specific metric, we can tighten rather than just do a standard deviation, 1 or 2 standard deviations off where you think that thing should be. You can say, well, this works in a similar fashion, or it follows a trend similar to this other metric. So if that metric starts to deviate, I expect this one to deviate. So we can tighten our bands a lot tighter than just watching a particular metric in isolation. The other thing that we do with that is we do some predictive analytics. So we trend about what we call 8 cycles. So if we have that 5-minute analytic cycle, it's about 40 minutes. We look into the future about 40 minutes and predict where that metric should be based on that. Right? So ultimately, does somebody have a question? I can hear some audio there.
You have some noise.
Okay, all right. So the short answer to that is it's multivariate regressional analysis. We do, there's 9 patents on the technology as it stands, mathematical patents, specifically around APM at this point. Originally, the technology was, for predictive analytics, applied to weather, applied to power distribution, but has been repurposed now for APM.
Great, thank you, Jay. A couple more questions. Surit was asking quickly, what's the version of APM being used? And also Sankar asking, when you have Introscope and CEM and ADA to look at application performance and customer experience and network latency, what is the exact use of Netuitive and how does it fit? Yes.
So let me go with Sankar's question first. Let me go with Surit's question. So the version of APM, we're using APM 3.0 for this one. It was, when we started, APM 3.0 was just being introduced at this client. One of the things that we found was it's not an out-of-the-box installation of that 3.0, right? So when we look at front ends and back ends and the way they were related, that didn't exist. Different branches were created, and different metric sets were actually pulled in via CA. So this is a big environment. Pulling in all of the available metrics was unscalable, right? It just didn't work. One thing was the number of metrics that were being collected from the front ends, as an example, is just the average response time, right? We're not even getting RPI from the front ends, just because it just would be a metric bloat if they were to do so. There's just so many of them. Okay, and then I guess to Sankar's question, let me just read this. When you have the Interscope CEM and ADA to look at the application performance, customer experience, and network latency, what is the exact use of Netuitive and Swim? So I guess the value add over and above what you've got is the dynamic thresholding. That's number one, so that you don't maintain all of those high watermarks and low watermarks manually. In this environment, it's huge. Number one, there's lots of them. They change regular. They're in constant continuous improvement mode. So there's not major, but I mean their releases. The changes they make are measured in the hundreds and thousands of changes to an application each time they release. Right. So it's impossible to do manual thresholding effectively in this environment. Number two is that end-to-end view, right? It wasn't just with the CEM, the ADA, and the Interscope. It was actually bringing in the queues and the BAM data, the store performance data. That stuff all together on a single pane of glass with nice red, yellow, greens that can be interpreted by level 1 and level 2 support without requiring all the domain expertise. In each one of those silos. So yeah, okay, all right. So does that, Sankar, that's a very big question. So I hope I've done it justice.
Thank you, Jay. And one more question from Fred about the data collection. So what and how is the data extracted from the MOM again?
Okay, all right. So from the MOM, what we're gathering basically the metric data, RPI, responses per interval, and ART, average response time, wherever available for each one of the components. So those are the two metrics that we feel are the most valuable from a front-end perspective and from a back-end perspective. And from a perspective of application performance monitoring, right? What is also available is, you've got memory, CPU usage, you've got, data about the JVM itself. We are collecting that, and we've seen some interesting things there as well. But specifically for the application monitoring, we're pulling out ART and RPI across the various different components. Right, so across the JSPs, across the transactions, across backend calls, and across JDBC calls, messages on queues, things like that.
I think the question is also on what extracts the data. So how is the data extracted from the MOM? I guess
okay. All right. Yeah.
Sorry.
All right. So we're just using the CL workstation command. We have a component which we call our Netuitive's remote collector, and on that remote collector is a CA plugin, right? And that plugin allows you to, or uses the CL workstation.jar under the covers to push a query in, right? So it just does a network-based query. You provided the regex, you provided the interval. And then, back comes the data in I believe it's just a big, kludge of metric data, right? So it's almost like a comma-separated stream of data that comes back, and then we do all the parsing on a separate server that's specifically designed to parse that and put it into the right spots for analytics.
Great, thank you, Jay. Any more questions?
And to ask a question, press star 1. There are no audio questions.
Okay, so if there are no more questions, we'll put up some polls. If anybody has a question during that time, we'll see it pop up in the Q&A, or you can dial star 1.
Yeah, this first poll has to do with the plan to do a in-person customer event or a series of customer events with APM users in your region. So here's an opportunity to vote on what would be first city to start with. Thank you. Customer event means sharing best practices, having presentations, updates from CA, and potentially some APM consultants and experts and users. And great, thank you. We move to the next poll, maybe. Oh yeah, what would be the preferred time of the day? I suppose it could be lunch and learn format during lunch, or breakfast and learn, so earlier in the day. Looks like lunch and learn is what preferred. That's the answer. We move to the next poll. Oh, and this next poll is feedback on today's webcast topic. Great. Thank you. Well, with that, Mary, we're getting to the end of the hour?
Yes. Nobody has any other questions, then we can wrap up the call.
All right. Well, thank you. With that, I'd like to thank Netuitive for their presentation, and thank Jay and Graham and their user, Amy, for their great presentation today. And thank everyone for participating, and we will see you at the next webcast in a month from today. Thank you, everyone.
I'd just like to say thanks for everybody that did attend. Appreciate you guys taking the time. And then, feel free to reach out if you have any, detailed questions. Always happy to answer anything about the predictive analytics side of things.
Thank you. Goodbye.